Okay, hello everybody, and welcome to a very brief lecture on research methods in abnormal behavior. This is for Psych 205, Abnormal Psychology, and the reason that I'm doing this in a video fashion is because this is very much review, especially because I know that you've taken Psych 101, so you've already gone over all the different types of research that are going to be present in this lecture. So it is a review, and if you've taken more than one social science or even some of the hard sciences, these are going to be very redundant. So I just want to go over a brief review of research methods. When we talk about specific research that has led to breakthroughs in psychiatry and psychology, we will go through the research methods that are used, and there'll be an additional review at that point. But just to give you a brief refresher, I want to make sure that we do go over this and make sure that you understand what the different types of research are. So when we're looking at this notion of research, we first have to have a good operational definition of what research is all about. And research is basically just the systematic or scientific search for facts using observations or investigation. And so we can replace those two words, observation and investigation, to say correlational research and causal research, or correlational research and experimental research. All of those words should at least be ringing a bell as the different types of psychological research we went over in Psych 101. But the whole point of research is that we have good accuracy, that what we are looking for is actually what we find, and that if we find it once, we can find it again. So immediately, that should be also ringing a bell, and you should be remembering that there are different types of validity and reliability issues in research. Validity is that we are finding what we are actually looking for, we're studying what we're supposed to be studying, and reliability is that it just didn't happen one time, that it could happen multiple times, and in good research that brings us to a good, valid scientific theory, it will happen every time that the parameters are correct, okay? So the only way to figure this out is to fully test the theory, or start with the hypothesis, the question, and then build it up to a hypothesis that's been shown over and over and over to be accurate, and then we can later call it a theory. There's a bit of a disconnect in people who think they understand what the scientific method is and people who really understand what the scientific method is. When you say theory, a lot of people think that means that it's not tested, or it's just something that somebody came up with. When in actuality, in science, a theory is the highest level you can attain. If it's a theory, it's been proven over and over and over. What some people will point to is to say, well, we've had theories in the past that have been shown to be accurate over and over and over, and then they've been thrown away when new information is found. That doesn't negate the fact that at the time that theory was found to be accurate, that it wasn't accurate at that time. It may not be accurate with the measuring tools that we have today. It may not be accurate with the additional information that we have today that we did not have 50 or 100 years ago. It was accurate for that time, and that seems like an excuse or a disconnect, because how can something about human nature be true at one time and not true at another? Well, that basically because we are getting so much better at measuring, and we're getting so much better at being able to look deeper into things. We didn't have, in the 1910s and 20s, we didn't have fMRI machines. We didn't have EEGs. We didn't have all these very precise measuring apparatuses. And so for what those individuals at that time had, they were pretty darn accurate. We get more accurate, and so the theory may get modified based upon knowledge that we have. And we may actually show that some theories are incorrect. But that doesn't negate the fact that at the time it was the most correct thing that we could have had. So when we are looking at abnormal psychology, you'll remember from lecture 1 that we have clinical researchers and clinical practitioners. Clinical researchers try to discover those theories, those universal laws or principles that we can apply to people across a broad spectrum, okay? So that's nomenclatical understanding, or basically a global understanding. These individuals, again, they're not there to assess, diagnose, and treat people. Treatment may be a part of research because they're testing a treatment, but the goal fortunately or unfortunately, is not the betterment of the client, it is the betterment of the science. And as a byproduct, the individual may get better. Their symptoms may be reduced because they're getting a proposed treatment, but it's not really the goal. And we have to remember that in the experimental method, I'm getting ahead of myself a little bit here, but if we're testing a new psychotropic medication, we're going to have a control group. So we're going to have half the people get the actual dosage of the proposed psychotropic med, and we're going to get half the people to get the control or the placebo. And so if we were really wanting to treat or cure people, we'd want everybody to get the actual dosage and nobody get the placebo, but then we would never know if the actual medication is doing it or if it's a placebo effect. So that is a huge difference. The researcher has to take out of the equation the notion of healing. Healing is a byproduct, or not healing necessarily, because we never heal in the psychological arts, but symptom reduction is not the key. If symptom reduction is a byproduct, then that just proves that this new drug or this new treatment will work, okay? So when we are doing research on individuals, it becomes very important that we use the right type of research. And in Psych 101, we talked about essentially 4 different types of research, 3 of which are correlational research, and 1 has a causal influence, that it actually shows causal relationship between 2 variables. The first one is a correlational study that we're going to talk about, the case study, or the correlational research method. The case study can provide a very deep and detailed look into a psychological problem. It may offer support for a theory, or it may postulate a new theory, but it doesn't have the wide breadth that other types of research have to actually completely introduce a new theory. And that reason is because a case study is going to be done on a very small population. And it's for a couple of good reasons. A case study might be performed on a group that is not accessible anymore. So if we're looking at historical individuals, we might do a case study, or an archival analysis. It's a different type of case study, different type of correlational research that we don't go over too much here, but it kind of falls under the same umbrella as case study. Maybe it's a group that we can't ethically observe. If I wanted to know the sleep-awake patterns of serial killers, should I do a natural observation? No, absolutely not. A, it's unsafe. B, I don't want to sit there and watch the individual engage in the maladaptive behavior, destructive behavior, just because of research. So if I wanted to know the sleep-awake patterns of serial killers, I would do a case study, and I would look back backwards and see what their sleep-awake study, or what their sleep-awake patterns were. Might it give me a little bit of skewed data? Yeah, because we're basing it on memory, we're basing it on anecdote, but we're not going to sit there and watch people do something maladaptive. So there's a bias of the observer, that I'm looking for something when I'm in a case study. So I'm probably looking for weird sleep patterns in my serial killer study. It is quite subjective. If I ask a serial killer who has been caught, how was your sleep patterns while you were actively engaging, then they may not be the best, most reliable reporter. And then really, if you think about it, I'm going to get good information about a very small sect of people, but I really can't use that information to generalize over a large population. And I can't extrapolate it out past where it is. I can't say that because I found 100% correlation between insomnia and serial killers, therefore the transverse is true. I should be worried about people with insomnia maybe becoming serial killers. That's not the case. So there's limitations to a case study. So that is a correlational method. It is just saying that A and B have some relationship with one another. The correlational research really can give us a really deep and wide look at something, but it doesn't allow us to really prove anything. It just says that these 2 things happen at the same time. So the experimental method will allow us to prove that something causes something. But the problem is, it's so hard with human subjects, because human subjects, let's be honest, are difficult to deal with. They change. They have different things going on. They're not just focused on one thing. So if we believe we're controlling everything except for the variable that we're testing, we're really not. in the best controlled study that we can have, we still have human differences, just the human element cannot be overcome very well. And so the correlational method, a correlation is the degree to which characteristics will vary with one another. Okay, so there's a co-relationship between A and B. So when we're looking at who we're going to study, we're looking at the population. The population is everybody who could possibly be researched in the study. So instead of serial killers, let's say I want to do a correlational method on the sleep patterns of community college students in Indiana. Well, my population is anybody who attends Ivy Tech across Indiana. Can I do a study with all of those people? I could, but I would have no sleep myself and really no life, and I would probably I would probably not be able to keep up with the changes in student population before the next semester comes. So I have to get something called a sample, and a sample is a percentage of the population that I think will represent the population. And then we have to add in that term representative, because a sample is just I grab 10% of the population. A representative sample is I'm going to find variables that I think are intriguing. So maybe I want to have a representative sample based upon gender, or based upon majors, or based upon age. Those are the representations that I want to be careful in getting my sample. So if I know that Ivy Tech is 60% female, 40% male, I want 60% of my 10% to be female and 40% of my 10% to be male. Or if I know that, if things break out into a certain amount of a percentage of the students are in this age bracket and a certain percentage are in this age bracket, I want that to match in my 10% or 5% of the whole population that I'm actually going to study. What becomes cumbersome is if you try to make it too representative. So if you try to make it so that you are looking at age and gender and major, well, there may be very, very, your sample of each individual little group is going to be very small. Because if you think about it, we have, let's say that we break it into 10 different age groups, like 18 to 30, 30 to 45, and so on. And then we have, for the purposes of this study only, we have two genders, or let's say three, let's say male, female, and non-differentiated, or somebody who doesn't want to identify. And then we have majors. Holy cow, we have, let's just say 100 different majors. Let's make it simple. Well, then if I want to get even 10,000 different students in my sample, let's just take two. To make it simple, let's make it gender and major. And let's go to two. Let's go male, female, and let's go, so instead of gender, we're going to call it sex to be accurate. So male and female sex, and 100 different majors. So I have 200 variables, or 200 different groups that I want to get a sample for. And my sample size may be, I don't know, let's say 10,000. That's only 50 people on average for every sample size. And that really doesn't represent very well. So you have to be very careful with deciding, you want to be careful to pick what representation you want within your sample, okay? So a correlation can be graphed, and this is not a math course, but you should remember that when a positive correlation is going to slope upwards and to the right, a negative correlation is going to slope downwards and to the left, and if the dots are all over the graph and you really can't find a line, that means there's no relationship and there's no correlation, okay? Just a quick refresher, these should all be popping up in your head as something that went over in 101. And so the magnitude or the strength is how closely those dots on the grid come together. So if you have a very nice line that goes up and to the right, and all the little dots are inside that line really nice and tight, and you're going up and to the right, that means that you have a high magnitude correlation. If it's going up at about a 45-degree angle, that means that your magnitude is going to be around 0.1. 1. It's going to be very close to a 1-to-1 ratio. And so that would be something like, for every hour you study, the increase in your final exam grade. Now, I know that that's not going to be a 1-to-1 ratio, but just theoretically think about it. If you study for 1 hour, most of the students get a D. You study for 2 hours, most students get a C. You study for 3 hours, most students get a B. You study for 4 hours, most students get an A. That would be that'd be a perfect or close to perfect positive correlation with a very high magnitude. If the numbers are splotched all over, but you can still see a line going through it, that'd be a low magnitude. It would mean that there's not a strong correlation between the two. Okay, and so again, remember, correlation coefficient is basically just the percentage of correlation. So +1 is a perfect 100% positive correlation. -1 is a perfect negative correlation. The positive or negative indicates the direction. So positive means it's going up, left to right. Negative means it's going down, left to right. And if you think about it, that's the same thing. That 1.00 is the same thing as 100%. So 100% correlation means that as one goes up, the other goes up exactly the same, and down for a negative correlation. Remember, when you're looking at the power of the correlation, how powerful the correlation is, you drop the percentage sign. Because if you're looking at pure correlations, the +1 and -1 have the same power. As one goes up, the other goes up. As one goes down, the other goes down. But if it's a perfect correlation, that's a 1 or a -1. So if you're looking at powers, you drop the plus and minus. So we look at the experimental method, and we know that the experimental method is different because it's not correlational. It's causal. It's manipulated variables versus variables being observed. So the manipulated variable is the research variable, the experimental variable, and the variable being observed is the control variable, okay? What we're doing is we're seeing, does a particular therapy or a particular intervention relieve the symptoms of a particular disorder, okay? If we want to know if this is the case, we could do a correlational research. There's nothing to say we can't. We can say that, you know, as we observe individuals, they are asymptomatic more often after they get treatment than before they got treatment. But that doesn't tell us that the treatment caused it. It could be something else. So experiments hold everything else to be as close to static as possible for the two groups with one manipulation thrown in, okay? So we have a couple of things we have to have here. We have to have a control group, the group that gets the placebo or doesn't get the treatment, but there isn't a knowledge that they're not getting it. So the control group has to be blind. They have to get a placebo to believe that they may or may not be getting the treatment. Random assignment means I can't cherry pick the ones that I think will do better with the treatment. I have to just randomly assign people. And then we have to have a blind design, which means, and you've probably heard of blind design, triple blind, double blind. Double blind is the most popular. Blind essentially means that the researcher is not going to interfere. If you remember, or if you've ever heard of the Stanford prison experiment, first off, not an experiment. It was more of an observation, naturalistic observation. But the major flaw was that Philip Zimbardo, the individual who actually put forth and conducted the Stanford prison experiment, was not a blind design. He was involved as the primary researcher and the quasi-warden of the prison that he created. So he wasn't blind to what was going on. He was actually manipulating things to try to keep the observation or research going. So a blind design is, I bring in somebody who I tell them, this is what's going on, but I don't give them what I think my hypothesis is, or I don't tell them what I want my results to be, because I'm going to be biased. And then a double blind design would be, I get someone to get someone, so that there's two layers of protection between the truth of what I'm trying to get at and the person who's actually administering, so that there's not a bias there. And so the groups are basically just the ones that get the intervention and the ones who are getting the placebo. And we compare the two groups, we can see if the independent variable had an effect on the dependent variable. And basically what we want to see is, if it is a successful experiment, the control group may have some people who, if we're doing like a treatment, a therapy, some of them might get better based upon the placebo effect. But we want to see a statistically significant higher group of people in the experimental group, in the research group, get better. So if I have 100 people participating, 50 in the control, 50 in the experimental, 10 from the control may get better just by happenstance or by placebo effect. And if I get 10 in the experimental group, well, then I didn't really show that my intervention does anything. But if I have 10 from the placebo or control group and I have 25 from the experimental group, then that's significant. That shows that I have a 50% efficacy over here. That's pretty darn good. I mean, even if I had 10 in my control group and 20 over here, I'm doubling it. I'm saying that, you know, double the people, got better, and that can't just be chance. That can't just be placebo. There probably is some validity to what I'm doing over here. Okay. So remember, we always have to do random assignments. It can be as simple as picking names out of a hat, flipping a coin. If I'm sitting in a classroom and it's a split classroom, so I have half my students on the left side, half the people on the right side, you could say that splitting left and right is random assignment because there's really no rhyme or reason to it. However, you have groups of people who tend to sit together for a reason. So it's not really randomized. What I would want to do is do like a random number generator or something to not allow for people's personal social desires, personal social inklings to influence my random assignment. Have there been some flawed studies? Oh, absolutely, absolutely. Some of them have been nefarious in nature. Some of them have been just poor scientific ways of putting things together. A couple examples here. The Spitzer study presented a paper at a meeting of the APA called reparative therapy, also commonly known as conversion therapy, for gay men and women. The research showed that undergoing reparative therapy, the gay men and women could change their sexual orientation. 11 years later, he asked for the paper to be retracted because it had a negative effect on the gay community. And it wasn't just because of the negative effect. It was because even though you could force a behavioral change in somebody, what was found was that there wasn't really a true change in orientation or in the inner sexual being of the individual. So we have to be careful with that. You also may have heard of the research in the past that was shown to correlationally, but the researchers did a really poor job of presenting, where it said that autism was caused by vaccines. If you don't know, that all the publicity was on that study, and there was tons of people who stopped vaccinating children because they were afraid that it was causing autism. That got a lot of publicity. What did not get a lot of publicity outside of the psychological and medical community was the fact that later that study was shown to be completely flawed, and to the point of numbers were fabricated in order to make the correlation seem like they were something that was actually a causal impact. And that has been debunked. The researchers that, I believe it was Oxford, are no longer, they had their research credentials taken away, and that research has been debunked multiple times. And so the reason we do blind designs is that point exactly. In that research that was done on autism and vaccines, the researcher had a belief beforehand that there was this correlation between the chemicals in the vaccines. It wasn't necessarily the vaccines; it was the holding chemicals, the preservatives that were in it that were causing, they believe was causing autism. So they had this vested interest in finding a correlation in their research, and they did not do a good job of being blind about it. And so that's to avoid bias. If they would have gone double blind, the people who got the actual numbers would have come back and said, we don't see any correlation between these two variables, or we see a very tenuous correlation between these two variables. And so that's why a double blind design is used. The other thing that you need to know is that humans and animals both need protecting in psychological research. We'll focus on humans here, but the process for animals, use of animals in research is just as tenuous. Almost every research university and college has what's called an IRB. And you may have heard it called something else. You may have heard it called an HRC, or a Human Rights Committee. Human rights committees are normally used in situations where theoretical interventions are being used on individuals, and the hypothesis is going to be tested on the individual in vivo. Okay, so I've done a lot of work working with individuals with developmental disabilities, intellectual disabilities, autism, Down syndrome, and people who do that work are called behavioral psychologists or behavioral therapists or behavioral consultants. And what they do is they do what's called an applied behavioral analysis, or a functional behavioral analysis, where you look at the behavior that is maladaptive to the individual. And based upon that, you come up with what you believe to be the function of the behavior. So the behavior may be physical aggression. So when Bob gets physically aggressive at day program, and we observe and we observe and we document, we find out that every time it gets above 80 degrees on the work floor, Bob gets physically aggressive. So the function of the behavior appears to be what we call non-social, or something, an internal feeling or physical discomfort. And so the hypothesis is, when Bob gets too warm at work, he will get physically aggressive to communicate that he is uncomfortable. Okay, so the intervention would be to try and teach Bob a verbal prompt to let people know when he's getting uncomfortable, or to have Bob take a time out from work and just walk away and walk into another room that's cooler. The Human Rights Committee would look at that and say, does this violate that individual's human rights? Does it violate, their safety and security? Okay. Institutional review boards basically do the same thing for research. It's an ethics committee to say, is the results that you are trying to get from the study worth the potential harm that may come to the individual? Because there may be a little bit of harm. Now, we look at historical studies, there's been a lot of issues with things that didn't go through institutional review boards. Things like, the aforementioned Stanford prison experiment, the Milgram study, Little Albert. Those are all examples of things that would not pass institutional review boards today, because the results are not worth the trauma that is caused to the individual. So it's all about making sure that the individual who's getting research done to them is safe. Now, there are some things that are just inherent within research. One of them is deception. And institutional review boards have to look to see, is the deception warranted and is it needed? Because if I tell you when you're coming in to do a study, I'm like, I'm going to give you $50 to participate in this study, and I'm perfectly honest with you. Let's say I want to do a study on how long you will sit and wait in a waiting room without somebody coming out and telling you that what's going on. So I say, come in for the study, sit here, and I just watch you and see how long you will sit there and wait before you finally just walk out, okay? That's not gonna do a lot of harm to people. It really isn't. But I have to be deceptive to you, because I can't just say, I'm gonna see how long you sit there, because that's gonna skew how long you sit there. So I have to just say, okay, so you need to come in and sit here, and someone will be with you momentarily. And then we watch. So the deception is there, but then I have to debrief you afterwards and tell you what I was getting at. Now, the debriefing may come sometime after, because in a college setting, I wouldn't want the first person to come in, do the experiment, and go out and say, oh, this is all about seeing how long you'll wait and sit. Well, that ruins the study for me. So I may have to debrief you later, but eventually I have to debrief you to let you know what was going on. And that's what the institutional review board is all about, is making sure that it's ethical and it doesn't harm somebody too bad. So participants have to enlist voluntarily. They have to have informed consent to the point at which we're not giving away what's going on. They can end their participation at any time, so it's not like you can force them to continue. The benefits outweigh the cost and risk. That's the biggest thing. They're protected from physical and psychological harm. Participants have access to information about the study, and you protect their privacy. So we're not going to publish the names and information of people. We're just going to collect basic data that cannot indicate who that person was. So that's a really brief review of what's going on in research in abnormal psychology. I hope that this helps you to remember some of those things, and it sets us up for the next couple of sections where we're going to look at the different models, and then the functional part of abnormal psychology, which is testing and assessment. So thank you for your time, and if you have any questions, please don't hesitate to email me or contact me, and I'll be happy to help you out.